creating neural network and single-solution human-based metaheuristic methods of solving the traveling salesman problem. Object, subject, and goal of the research. The object of the research. The process of finding solution to optimization problems. The subject of the research. Methods for finding a quasi-optimal solution based on metaheuristic and artificial neural networks. The goal is to increase the efficiency of a quasi-optimal solution search to the traveling salesman problem using neural networks and metaheuristic methods. To achieve this goal, it is necessary to solve the following tasks. Create an optimization method on an artificial neural network. Create an optimization method based on a single-solution human-based metaheuristics. Conduct a quantitative study of the proposed optimization method. Self-organizing feature map. Initialization. Calculation of the distance to all neurons of the network. Calculation of the shortest distance and selection of the neuron with the shortest distance. Setting the weights of the winning neuron J-mu and its neighbors based on the calculation of the center of mass of the J cluster. Checking the completion condition of training. Calculating the distance to all neurons in the network. Selecting the neuron with the shortest distance. Iterated local search. Initialization. Iteration number n equals to 1. Performing a perturbation. Local search based on 2-opt. Determine the best solution. Condition for terminating the search for a solution. Search with a variable neighborhood. Initialization. Iteration number n equals to 0. Neighborhood size z equals to 1. Create a neighborhood. Vector x is randomly selected from the neighborhood U. Local search based on 2-opt. Determine the best solution. Determine the neighborhood size. Condition for terminating the search for a solution. Greedy randomized adaptive search. Initialization. Iteration number n equals to 1. Running a greedy randomized procedure. Local search based on 2-opt. Determine the best solution. Condition for terminating the search for a solution. Guided local search. Initialization. Iteration number n equals to 1. Local search based on 2-opt. The penalties are modified. Determine the best solution. Condition for terminating the search for a solution. Partial optimization metaheuristic under special intensification conditions. Initialization. Iteration number n equals to 1. The number of the solution component is randomly selected. Creating a set of vertex numbers. Optimization procedure, use of search with prohibitions. Determine the best solution. Condition for terminating the search for a solution. Anneal and temperature decrease function. Effective width of topological neighborhood. Comparison of the proposed SOFM training method with the existing one based on the criteria of time and path length. Comparison of the proposed single-solution human-based metaheuristics with the taboo search method. Conclusions. The urgent task of increasing the efficiency of methods for solving the traveling salesman problem was undertaken by creating methods based on artificial neural networks and single-solution human-based metaheuristics. The proposed modification of the learning method for a self-organizing feature map uses setting weights of the winning neuron and its neighbors based on the calculation of the center of gravity. This allows for accelerating the training of this neural network due to parallelization in case of GPU use. The effective dynamic width of the topological neighborhood for calculating the topological neighborhood function, which allows to explore the entire search space at the initial iterations and make the search directed at the final iterations. This ensures a high accuracy of the search through this neural network. A modification of single-solution human-based metaheuristics is proposed that allows potential integer solutions and uses a 2-opt permutation in the case of a local search neighborhood creation and a 4-opt permutation in the case of a global search, which allows adapting these metaheuristics to solve the traveling salesman problem. The proposed methods make it possible to expand the scope of application of the self-organizing feature map and single-solution human-based metaheuristics, which is confirmed by their adaptation to the traveling salesman problem and contributes to improve the efficiency improvement of intelligent computational systems. Prospects for further research are the study of the implementation of the proposed method on a broad class of artificial intelligence problems.